In this video, we'll discuss the t-distribution. In chapter 14, we used the z-distribution to solve problems of inference. And to find the one-sample z-statistic, we used the formula z equals x bar minus mu divided by sigma over radical n. The distribution for the z-statistic here was the standard normal distribution. The standard normal distribution has center 0 and standard deviation 1. In the real world, if we had to solve a problem of inference, it would be impossible to find sigma. So instead of using sigma, we would substitute sigma with something close, which is the sample standard deviation, S. So the standard deviation that comes from the sample. Now, if we use S instead of sigma, now we are no longer going to have the standard normal distribution. The distribution is going to look a little different. What we have now is the t-distribution. It has center 0, just like the standard normal distribution. So look at this figure and you'll see the comparison of the standard normal distribution with the t-distribution of degrees of freedom 2 and degrees of freedom 9. So notice that the tails of the T9 distribution and the T2 distribution are thicker than the tails of the normal distribution, which is the standard normal distribution, which is in blue. So the t-distribution is slightly different than the standard normal distribution, and it depends on the sample size, which gives us the degrees of freedom. So degrees of freedom is 1 less than the sample size. Now let's discuss the 3 properties of the t-distribution. So the t-distribution looks a lot like the standard normal distribution. It is a bell-shaped curve, it is single-peaked, and it is symmetric about the number 0. The difference between the standard normal distribution and the t-distribution is that the area in the tails for a t-distribution is larger than the area of the tails in a normal distribution. But when the degrees of freedom increase, the t-distribution starts looking more and more like the normal distribution. So that is basically a comparison of the normal distribution and the t-distribution. Important note is that degrees of freedom is defined as 1 less than the sample size of. So if the sample size is 25, then the degrees of freedom is 24.